Good morning, Nine Harlow, and all of you in it. So let's just have a little review here of some exponential and geometric, same type of pattern things. So here we started with 160, and then we have 80, and then we have 40, and if you're paying attention, you can see that each time it's half of what it was before. And so half of 40, half of 20. There's those next two numbers. Okay, so you're looking for the multiplying number. Sometimes it's a fraction like this. Sometimes it's a whole number. Once you find it, put the next two terms in, you get it right. Okay. Find the initial value of the car. Okay, so you remember, I hope you remember, y equals beginning times the multiplier raised to the x power. The beginning, the initial value, what you started with. You started with $24,500. That's the initial value of the car. Is this number more than 1 or between 0 and 1? If it's more than 1, when you multiply by it, it gets bigger, which means it's growth. If it's between 0 and 1, that's like a fraction, means it's going to get smaller or decay. Okay? And then the percent, let's just put these numbers in while we're talking. 24,500, it's growth. By what percent does it change each year? Okay, so it's not changing by 1.25. Okay, timesing by 1, it would stay the same. Okay, 1 times anything is just the same as it was before you times by 1. What it's changing by is that 0.25. Okay, so I'm going to put 25% because it has a percent sign, and so it doesn't want it in decimal form, it wants it as a percent. Okay? So, again, now suppose this was 0.75 instead of 1.25. Well, then this would be decay, and we'd have to see how much is this different than 1. Well, it's minus 0.25. It's going down 25%. Okay? So, next problem type. Table for an exponential function. Oh, is it geometric, arithmetic, geometric, or neither? In other words, is it following a linear pattern or an exponential pattern or neither? So 27, 22, 17, 12. Looks like we're subtracting 5 each time. That makes that arithmetic. Okay, looks like here, 25, 36, 49, 64. Those are all square numbers, okay? It's not adding and it's not multiplying. It's actually a quadratic, which means it's neither arithmetic nor arith. So here, 1600, 400, 100, 25. Here we're timesing by 1/4 each time. 1/4. 1/4, which makes it geometric. Let's look at number 5, table. Okay, 6 to the x. 6 to the negative 2 power is the same as 1 over 6 to the 2 power. 1 over 6 squared. Okay, you can put this in your calculator. You can put this in and use the table function, and it'll give you the whole table, tell it to start at here and end here and go by ones. Or you can put these numbers in one at a time. 6 to the negative 2. 8th grade we taught you this is the same as 1 over 6 to the positive 2, which is 6 times 6. 1 over 36. Okay? 6 to the negative 1 is the same as 1 over 6 to the positive 1. Okay? So you're just going to fill the table in. 1 over 6. 6 to the 0 power is 1. 1 over 1 is 1. 1 over 6. So 6 to the first power is 6. Whoops. 69. And 36. Mr. D, you know everything. Yes, I know a lot. Not everything, though. Okay? Table. Writing an equation that models exponential growth or decay. Okay, here's another one. And this is all review, kids. This is all, we've done this before. In fact, I just took an assignment that you had done back in December and just went through it, and so I'm showing you once more. At the beginning, B is 1500. This area has decreased by 1.6. So 1500. 1 minus 6.1% or 0.061 as a decimal each year. So now you're going to write between y and t. So we're not going to use an x. So y equals b times m to the t power. B is 1500. The multiplier is 1 minus 0.061. Pick up your calculator. 1 minus 0.061 equals SROD 0.939. 0.939 to the t power. There you go. There's how you do it. Y equals 1500 times 0.939 raised to the t power. Put capital letters. I didn't, but it accepted them. However, you may have confused upper and lower case. Maybe I have my caps lock on. Well, I turned it off now. But anyway, that is how you do it. The beginning, and if it decreased by this, you do 1 minus this. If it increased by something, you do 1 plus something. Okay? So let's see, next kind of question. Finding a specified term, number 12. So if it wants us to find a term that's way out there, find the 14th term, we're not going to keep going times 3, times 3. Notice that's what's happening here. It's timesing by 3. Okay? Times 3. We're not going to do that 14 more times. What we're going to do is we're going to take this, paying attention to the fact that that's the first, not the B. It's not the beginning, it's the first one, okay? And we're gonna write our little y equals the first one times the multiplier. Not to the x, because we don't have the beginning. We have the first one, so it's to the x minus 1. And then we're going to put 14 in for x. So we're going to plug in our calculator 5 to the 3, 5 times 3 to the 14 minus 1, or to the 13th power. And we don't put the y in our calculator, so just saying. 5 times 3 to the 13th power, 5 times 3 to the 13th power equals 7971615. Correct, yay. Okay, so all I did is I remembered that when it's a sequence, I don't have the 0 term, I have the first one, which means I have to do x minus 1. And I found times 3 each time. First term, times 3 to the x minus 1. It told us to use the 14th term. That's 14 minus 1 term, 13. And I put it in the calculator, and I'm done. So good luck with this week's assignments. And we will talk to you in the mornings. Bye-bye.